Welcome. Let's take a look at using the substitution technique to integrate indefinite integrals involving logarithmic functions. Before we get started, let's just remind ourselves that the derivative of the natural log function, so derivative natural log absolute value of x, is equal to 1 over x, of course provided that x is not 0. So that means that the antiderivative of x dx is going to be the natural log of the absolute value of x. So with that knowledge, let's go ahead and take a look at these examples. Our first example is the antiderivative of the indefinite integral of 2 divided by 5x minus 1. So the first thing I want to do here is think of this as 2 times 1 over 5x minus 1 dx. And that's so that I can maybe focus more closely on the basic form that we have here. We have 1 over some quantity, 1 over something. And if we're wanting to integrate 1 over the variable, we know that the antiderivative is going to be the natural log of x. So this 2 really is just a constant multiple of what's going on in this particular integral. So let's go ahead and put it in front of the integral symbol. So now we're focused on how do I deal with integrating 1 over 5x minus 1. Well, I've got 1 over stuff involving my variable, 1 over an expression involving a variable. And so in the back of my mind, I'm thinking this is kind of like finding the antiderivative of 1 over x. So maybe what I want to do is take this whole denominator, this 5x minus 1, and see if I substitute that expression for u, that I get something that is easily integrable. So let's go ahead and say let u equal 5x minus 1. Then our differential du will be u prime of x dx, which means in this case u prime of x is 5. So our differential should be 5 dx. Now currently we don't have a constant 5 in here multiplying our function. However, that's easily fixed. We can multiply by 5 and 1/5 because 5 times 1/5 is 1. So let's go ahead and multiply by 5 here and 1/5 here. So if I do that, and I can go ahead and combine and multiply this 2 and this 1/5, I'll get 2/5 the integral of 1 over 5x minus 1 times 5 dx. And now I can replace my 5 dx with du, and I can replace my 5x minus 1 with u. So now my integral looks like 2/5 the antiderivative of 1 over u du. And that's a basic form, something that's rather easily integrated. So the antiderivative here is 2/5 the natural log of the absolute value of u plus our constant of integration. And then we have to back substitute in what u is. We said that u is equal to 5x minus 1. So we have 2/5 times the natural log of 5x minus 1 in absolute values plus c. Now, in our next example, we've got 3 times the natural log of x raised to the 5th power times 1 over x dx. Now, something that I'm noticing as I look at this question, this integral, is that I've got natural log of x raised to a power. So this natural log of x is inside a 5th power function. And then I've got this multiplication by 1 over x. And I know this relationship that the derivative of natural log of x is 1 over x. So I can recognize there's a derivative relationship here. So since the natural log of x is an argument in this 5th power function, let's go ahead and try to let u equal the natural log of x and see what happens. Sometimes when we're doing problems like these, we may have to try 1 or 2 different choices for u until we come up with the correct one. So if u is natural log of x, then du, our differential, should be u prime of x dx. And in this case, du should be 1 over x dx. And notice that I do have 1 over x dx that can serve as my du. And I have natural log of x, which can become simply a u. So as I rewrite this, then I'm going to bring my constant 3 out front. This natural log of x to the 5th power, that's just going to become u to the 5th power. And then this 1 over x dx, that's just going to become du. And now I can go ahead and integrate this. I'll get 3 times. Now I'm going to add 1 to my exponent for u, so that's u to the 6th power. Then divide by that exponent, 6, plus c. My 3 and my 6 can simplify. So I've now got u to the 6th over 2, and now I just need to substitute back in what u is. We said that u was the natural log of x. So we'll have natural log of x to the 6th power over 2 plus c. And there's our antiderivative. I hope you find this helpful.